In this video, we're going to look at the next type of a non-homogeneous second order differential equation where the right hand side is equal to something times x squared, or in the form of k times x squared. So we're going to do what we always do. We're going to work out the auxiliary equation. So that's going to be m squared minus 5m plus 6 equals 0. Hence, solving the quadratic, we get m minus 3, m minus 2 equals 0. Hence, m equals 3 or m equals 2. Therefore, we can say the complementary function is y equals to a times e to the power 3x plus b times e to the power 2x. So because our fx is in the form of 3x squared, our particular integral, according to our table, is cx squared plus dx plus e. Now, some textbooks might use lambda, mu, and gamma respectively, for example. It doesn't matter what you call them, they're just constant terms. Just for consistency, because I've called the coefficients in our complementary function a and b, I've just tried to be consistent by calling it c, d, and e in the particular integral. But it doesn't matter what you call it, it's your own preference. So we can say that we can assume that our particular integral is in the form of y equals cx squared plus dx plus e. Differentiating this, we get dy by dx for our first derivative is 2c x plus d, and then the second derivative dy by dx squared is just simply going to be 2c. So now what we need to do is we need to substitute this into our differential equation. So it's going to be dy by dx squared is going to be 2c, and then it's minus 5 multiplied by what we have for dy by dx is 2c x plus d, like so, and then we've got plus 6. Now y must be the particular integral form, so that's going to be cx squared plus dx plus e, and now all of that is equal to 3x squared, so I'm going to write that here. So expanding everything out, we get 2c minus 10cx. Then we're going to have minus 5d plus 6cx squared plus 6dx plus 6c. Now all of that is equal to 3x squared. Now, because we're going to equate the coefficients of x squared and equate the coefficients of x, then equate the coefficients of the constant terms, what we're going to do is we're going to group the like terms together. So we've got 6cx squared. Now there's no other x squared term, that's fine. And then I've got a 6dx, which is a coefficient of x, and I've got a minus 10c, so I've got minus 10c here, put the x on the outside. Now with my constant terms, I've got 6e, which is here. I've got a plus 2c, and I've also got a minus 5d. Now all of that is equal to 3x squared. So now that I've grouped all the terms together, it's going to make the equation of coefficients a lot easier. So the next step we're going to do is to equate the coefficients of x squared. And we can see that 6c must be equal to 3. So So c is a half. Now we're going to equate the coefficients of x. So we're going to say equating the coefficients of x. Well, that's going to be 6d minus 10c. Well, there is no coefficient of x on the right hand side, so that must be 0. So we're going to say 6d minus 10c is equal to 0. So we can say 6d minus 10 times a half equals 0. So 6d minus 5 equals 0 here. So we can say d is 5 over 6. So now we're going to equate the constant terms. So we're going to say equating constant terms. So that now is going to be 6e plus 2c minus 5d. So 6e, going back to what we have, plus 2c minus 5d. Okay. Now notice that there is no constant term on the right hand side, so that's going to be equal to 0. But we do know what c and d are. So 6e plus 2 times a half minus 5 times 5 over 6 respectively equals 0. So 6e plus 1 minus 25 over 6 equals 0. So we can say 6e plus, we can say 6 over 6 minus 25 over 6 equals 0. And we can say that 6e minus 19 over 6 equals 0. 6e is equal to 19 over 6, like so, and therefore e is 19 over 36. So hereforth we can say that the particular integral is y equals, I'm going to write the original form first, cx squared plus dx plus e. So in our case, we know that c is a half. That's a half x squared. Please make sure fractions have a horizontal line, not a slash, okay? Because that would be incorrect. It'll be. So if I write 1 over, that's 1 over 2x squared. That's not the same as a half times x squared. So be careful in your legibility, in your writing in examinations. So y equals to a half x squared, then we know that b is 5 over 6, so it's plus 5 over 6 times x, and we just worked out e to be 19 over 36. The overall function is y equals cf plus pi. So in our case, y equals a times e to the power 3x plus b times e to the power 2x, and I'm just going to write particular integral in pink for legibility. So it's plus half x squared plus 5 over 6x plus 19 over 36 is my solution for the general solution. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we have a non-homogeneous second order differential equation in the form of kx squared. So we're going to first work out our auxiliary equation. So we're going to say that m squared minus 4m plus 5 equals to 0. So we can say that m is going to be 4 plus or minus square roots of minus 4 squared minus 4 times 1 times 5 all over 2 times 1. That will give me 4 plus or minus 16 minus 20. That's going to be minus 4 here over 2. So I get 4 plus or minus 2i over 2. Hence I get 2 plus or minus I. So our respective complementary function will take the form of y. Don't forget, it's always e to wherever the real part is. So it's 2x times a cosine of x plus b sine of x, because we've got one I essentially here. Now notice our differential equation is in the form of 25x squared minus 7, or in the form of kx squared. So it needs to be cx squared plus dx plus e. So we're going to say that we're going to assume that our particular integral will take this form, cx squared plus dx plus e. So we could say that dy by dx is 2cx plus d d2y by dx squared is simply 2c. Now we're going to substitute this into our differential equation, which is 2c minus 4 times dy by dx, which is 2cx plus d. And we now need to have 5 times our particular integral, which is cx squared, because that's what y is, plus dx plus c is equal to 25x squared minus 7. So again, we're going to expand the brackets out here. So it's going to be 2c minus 8cx minus 4d plus 5cx squared plus 5dx plus 5e equals 25x squared minus 7. So as we did in the previous example, we're going to collect the like terms. So I've got 5cx squared. Now let's get the x terms together. So it's plus 5d minus 8c. There's no other coefficient of x there. Now we've got to get the constant terms, so that's plus 2c minus 4d plus 5e. Now all of that is equal to 25x squared minus 7. So we're going to equate the coefficients of x squared, so equating the coefficients of x squared that's going to be 5c is equal to 25, so c is equal to 5. And now we're going to equate the coefficients of x. So equating the coefficients of x. So that's going to be 5d minus 8c, but remember in this particular example there is no coefficient of x on the right hand side, so that's going to be equal to 0. So we can say that 5d minus 8 times 5 is equal to 0. 5d minus 40 equals to 0. So 5d equals 40, so d must be 8. And now we're going to equate the constant terms. So let's write it down, equating the constant terms. So equating the constant terms so we have now that 2c minus 4d plus 5e. So 2c minus 4d plus 5e. Let's go back and double check that. So it's 2c minus 4d plus 5e is equal to minus 7. So that's equal to minus 7. So we know that c is 5, so we can say 2 times 5 minus 4 times 8, that's what d is, plus 5e is equal to minus 7. So we can say 10 minus, well, 4 times 8 is 32, plus 5e is equal to minus 7. So we can say minus 22 plus 5e is equal to minus 7. And we can say that 5e is 22 minus 7. So 5e is equal to 15. E must be equal to 3. So we can say from there that our particular integral is going to be, as we stated, y equals cx squared plus dx plus e. So we write our coefficients in. So we said that we worked out that c was 5, d was 8. So it's going to be 5x squared plus 8x plus the value of e we worked out was 3. So now we can say that the general solution is always y equals the complementary function plus the particular integral. So the general solution in our case, y is going to be e to the power 2x a cos x plus b sin x. And I'm going to do the particular integral in pink, just for clarity. So plus 5x squared plus 8x plus 3, which is our general solution.